Hello everyone, welcome to Imperium. I will be teaching you all the concepts of OOP with the help of C++ language. So basically C++ language is an extension of C and it is also called as C with classes. So C++ is included in OOP where OOP stands for Object Oriented Programming. So there are basically three types of programming languages. One is procedural programming, second one is modular, and the third one is object oriented programming. So why are we supposed to learn OOP? Why are we supposed to learn OOP? What makes OOP more interesting? Why is OOP every time, um let's say, why is it hype? So it is hype because of the concept that OOP uses. It uses inheritance, polymorphism, encapsulation, which are very effective and efficient for coding. So we'll eventually learn about them in further lectures. As this being the very first lecture, I will be giving you all the Hello World code and I'll be telling y'all and I'll be showing you all the extension what you all need to be downloading for using the C++. So without further ado, let's get started. For C++, we will be downloading Dave C++. That is where we're going to do the C++ coding and all. So let's get started. Type dev plus plus C plus plus download for Windows. Go here, the first link. Click on this one, and yeah, your download will start shortly. So Dev C++ is basically used only for C++. So this is what we're gonna use. C++ is a good language. You all will eventually have a hold on this language. You all will have a command on this language once you start practicing the language. Okay, yeah, it is done. Okay, okay, it is getting installed. Come on. This might take a time. This might take few seconds. Okay, come on, it's done. Yep. Okay. Please select the language English. Yes. I agree. Next. So now that we have downloaded Dev C++, let's just start working on that. Okay, so where is it? Downloads. Okay. Yes. The setup is being loaded. Select language English. Yes. I agree. Next. Install. Please do not change anything in this. Let this be as it is and just click on next, I accept, etc. Do not change anything in this. So we're gonna use Dave C++ as it is made for C++ specially. We're not gonna use VS Code or anything. We're gonna code in this. Okay, so yeah, it is done. Finish. And yeah, Control plus N. Let's write the Hello World program. Hello World program is the very basic program that everyone encounters in their life when they are about to code or when they start coding. It is the very first, very initial program that is introduced. So let's begin with that. So hash include IO stream. using main space std in main see out the world. Array. Okay, yeah. So as you all can see, this is the output that we get. Hello world. The code has been executed successfully. And this is the code. I hope you all practice this code. So this, I think let's stop here. This is enough for the very first lecture. We will eventually continue this in the further lectures. So yeah, that's it. Stay tuned. Thank you. Everyone, welcome back to Imperium. So our today's lecture is gonna be on the control statements, that is if, else, switch case, etc. In this lecture, I will also be teaching you all the syntax of class and object and how do we define class and objects. So without further ado, let's get started. And if we have time, I'll definitely tell you all about the access specifiers. So let's start. Okay, yeah, I've written this. I'll explain you this. So let's start with the control statements. Let's start with if. So I'll give you the syntax, and this is how the if statement is written. We write if condition curly brackets. That's it. This is the syntax of if. Let's check syntax for if else. If else. For that we write if condition curly brackets your code. After the ending of if we write else condition again curly brackets code, and that's it. This is the syntax for if and if else. It is not always compulsory to write the else statement as it is understood. If not, then this. So it is not necessary to write the else condition every time. So this is the basic syntax of the control statement if and else statement. Now let us no. I'll give you the code for switch case. Let's understand switch case with the help of the code itself. This code is basically the code for addition, division, multiplication, and division. This is basically a basic code for calculator, let's say. So I'll explain you the code and y'all will understand the switch case with the help of this code. So here hash include iostream. In first lecture, I have told you hash include iostream. Iostream is a library. Int main. Here we have used int num1 and num2, where int is the integer and char is the int and char are the data types. Here cout is used to represent what we want the user to see. That is cout enter the first number. Cin we take the input using cin in num1. We do the same for operator and same for num2. Now after this we take the switch case. This is the syntax switch case. In the normal bracket parenthesis we write operator. Case 1 cout result. Here we do num1 plus num2 break. If case minus cout result num1 minus num2, and this is how we continue till the division sign. Here why do we use endl? Now endl is used to carry the statement on the next line. For example, if you write a paragraph and you want the next line, for example the continuous line, to be on the next line, so that is why we use endl. Endl is used to break the line there and continue the next word from the next line. Now here division. If num2 is not equal to 0, This is the sign for not equal to. If num2 is not equal to 0, see out result num1 divided by num2. Else, see out error division by 0. Now this is if it is not equal to 0, do the division, and if it is equal to 0, then show this condition. Break. In the switch case, there is always a default statement. Here the default statement is out error invalid operator. This program might seem a bit complicated, but this is very easy if you all understand. This being the very first program, you all might feel this is a bit confusing, but you all will get a hold on this eventually. Make sure you go through this program. This is a easy program, just you need to understand this program. It is a small program. So this is the basic switch case program. With the help of switch case, we have made a small calculator. Let's see, let's compile this and run. Enter first number, just a second. Enter first number 22, enter an operator, plus enter second number 11, result is 33. That means our code has executed successfully. Let's go back. So this is the switch case code. I hope you'll go through this code. This is not a very difficult code, but it is easy. It is very easy if you'll understand. Just go through this, and this is how a switch case is written. This is how a switch case is written. Make sure that you go through the sum. It is very easy. Now let's get back and let's get started with class and object. So what is class and object? Class is an user-defined data type. It is used to create a new data type. And objects are created as that of the class, where objects are the basic runtime entities. Now this is a very theory thing. Let's not get into theory. This you all will understand eventually with the continuation of lectures. So let me just give you all the syntax how to define a class and how to define an object. So let's start. Let's see first the syntax of class. Class, e.g. Let's say we take a class name e.g. This is how you define a class. You write the class keyword in front of the name, curly brackets, enter, access. So let us start with the syntax of class. So what is basically a class and object? We have discussed what is class and object. A class is a user-defined data type and the objects are created as that of the class. So let's see the syntax of class now. Syntax of class. Okay. So your class example, curly brackets, access method, code. So this is how we write the class, how this is how we define a class. We write the class word, the class keyword in front of the word or in front of the name that we want to give the class. For example, here class EG. So EG is a class. And here this is the main thing, this is the crucial thing, how we end the class. We end the class with a semicolon after the curly brackets. That is what indicates that it is the end of the class. This is the crucial thing. Now here, what is this? Access methods. So there are total three types of access specifiers. Access specifiers are public, private, wait, public, protected, and private. So we'll talk about this later. First, let's see the syntax of object, and then we'll come to access specifiers. So this is the syntax of class, and this is how we define a class, and this is how we write inside a class, or this is how we write a class. I hope it is clear, and let's move towards the syntax of object. Now, how is an object created? As we know, an object is created as that of the class. So let's see, let's take an example. Class animal. Class animal. Let's say public. Okay, here the class is ended. Int main animal a1. Now here animal a1 is the object. Your animal is the name of the class. Here, as we have taken class animal. So animal is the name of the class and A1 is the object. We have created A1 as the object of class animal. This is how we define an object. Here we can say anything like animal, but remember the animal word or whatever the name of the class is, that should be constant. So animal A1 is an object. We can even say animal 2 is an object. Animal C is an object. This is how we define an object irrespective of the name of the object. For example, A1, 2, C, irrespective of that animal, the keyword animal or the name of the class should be constant. This is the way of defining an object. I hope it is clear. The syntax of class and the syntax of object is clear. Now let us move towards the access specification or the access methods that we say. So there are basically three types of access specifications, access specifiers, that is public, protected, and private. So let's say that we have a code, we define a variable a is equals to 5. Now if we define that in public, so that variable is accessed over the whole code. That variable has the scope all over the code. That is what we mean by public access. Now, in protected, if we define a variable in protected, then the variable is accessed only by the code or only by the class where it is defined and the class that is immediately derived from that class. Now, this might sound a bit complicated and a bit confusing, but I'll explain this in detail. Let's see private first and let's move back to the protected. Now, here in private, if we define a variable a is equals to 5, for example, in class, so that variable will only be used in that specific class. That variable cannot be used anywhere else. That is what we mean by private. The scope is limited. In public, the variable can be used anywhere. Anywhere. Now let's see about protected. You're protected, let's say for example a class dog. We define a variable in class dog. Now we derive the class with the help of class dog, let's say a class puppy. Now class dog and class puppy can have similarities. For example, the color of the fur, their height, their DNA, their for example, yeah, then their height, their color, their DNA, their genes, etc. So this is what I mean by, if we define a variable in class dog, the puppy can access the class dog's variable, but the other species cannot. This is what is inheritance. You all will get a brief idea about inheritance when we talk about inheritance in the further upcoming lectures. But for basic knowledge, I hope it is clear with the protected access specification. Let's go through this again. In public, the variable can be accessed anywhere in the code. In protected, it can be accessed only where the variable is defined, that is in the class where it is defined, and the class which is immediately derived from that class. In private, the variable is accessed only where the variable is defined, only within that specific area. So that is it for today. I think let's stop here for today and make sure that you go through the switch case code, which is not very difficult, but if you're very sure, if you understand this code, it is very easy code. I think that is it for today's lecture, and tomorrow we will meet again. So, yeah, thank you. Back to Imperium. So, our today's lecture is only gonna be on inheritance and types of inheritance. So, what is inheritance? Inheritance is a mechanism that allows one class, let's say a child class, to inherit the properties and behaviors of the parent class. This allows for code reusability and establishments of relation between the parent and child class, where the child class can extend or modify the functionalities of the parent class. Now, this was the theory of what is inheritance. Now, let's see what inheritance is. So, inheritance is basically inheriting the characteristics or the features of parent into class. Um, for example, let's see our parents. Now, we inherit a lot of stuff from our parents. For example, our looks or our genes, the way our hair looks, our hair color, our hair structure, if it is curly, if it is wavy, if it is straight, that is what we inherit from our parents. Now this is an example of inheritance. Now inheritance is an important concept in OOP. So let's start with inheritance. So there is basically five types of inheritance. First is single, second one is multiple, third one is multi-level, fourth one is hierarchical, and the fifth one is hybrid. So in inheritance, first of all, there is a class, let's say the parent class or the base class. Now, this is where the class has the, let's say, the genes, for example, our parents, and child class are we. Child class, or let's say derived class. The class that are derived from the base class or inherited from the base class or parent class. I hope this is clear. So, parent class is which consists the, let's say, genes or variables or etc. or data, and child class is what inherits that from the parent class or from the base class. I hope this is clear and I'm not confusing you guys here. So let's move in with the type of inheritance. So there are basically five types of inheritance. First is single inheritance, single level inheritance, multiple inheritance, multi-level inheritance, hierarchical, and hybrid. Total five types of inheritance. So let's start with the first one, that is single inheritance. In single inheritance, let's say there is a single parent, or let's say there is a base class, base class, and there is a single child class. So that is what makes a single inheritance. Now let me give you all the basic syntax for single inheritance. Let's say base class, derived derived class, access method, access method, base class. Now this is the syntax for single inheritance, that is the derived class, access specification or access method, and the base class. Let's not see this. This is the syntax for single level inheritance, that is derived class, one derived class, access methods. We have studied what are the access methods in the previous lectures. There are total three types of access method. One is private, the second one is public, and the third one is protected. I hope you all are clear with this one. What is private, what is protected, and what is public. Let's not move into that and let's see inheritance today. So, derived class, access methods, and then base class. This is the syntax for single inheritance. Single inheritance, a derived class with only one base class, is called as single inheritance. I hope this one is clear. Now let's move to the second one, which is multiple. Now, multiple says that a derived class with multiple base class is called multiple inheritance. A derived class with multiple base class. Now let's say here are two, oh my god. Let's say here are two base classes, for example, A and B, and C is a derived class. Let's say base class 1 and base class 2. and there is a derived class. See, there is a derived class. Now let's see the syntax for multiple. The syntax is derived, D-E-R, derived class, access method, base, base class 1 and comma, base class 2. So this is the syntax. This is the syntax, and so is this. This is the syntax for single. This is the syntax for multiple. As one single derived class has multiple parents, that is parent 1, that is class 1, and class 2, base class 1, base class 2, and derived class is 1. So that is the reason why we call it as multiple. Let's move into the third one. The third one is multi-level inheritance. Now, in multi-level inheritance, a mechanism of deriving a class from another derived class is known as multiple inheritance. Let me repeat myself again. The mechanism of deriving a class from another derived class is known as multi-level inheritance. For example, let's say there is a base. For example, base class. Here, let's say we derive class 1, derived class 2. Here in multi-level, let's say there is a base class and the class 1 is derived from the base class, which is clear. Now, the derived class 2 is derived from the class 1 and not from the base class. Let me repeat myself again. Let me make myself clear. There is a base class. Class number 1 is derived from the base class, but class 2 is derived from the derived class 1. That is what makes the multi-level. You all can even understand multi-level in with the help of let's say family tree. For example, base class is our grandparents. The first derived are our parents and the second are we. That is the base class. Parents are derived from our grandparents and we are derived from our parents. That is what makes multi-level. Now let's see syntax for multi-level. Let's say derived class 1 access method base class, derived class 2 method. This is the syntax. Now this is the syntax for multi-level inheritance. I hope multi-level inheritance is clear. You can also remember multi-level inheritance as our grandparents being the very first class, our parents being the second class, and us being the third class. That is, the genes that our parents have or us we have are derived from our parents, and the genes that our parents have are derived from our grandparents. Let us consider this as an example of multi-level inheritance, which will make it more clear. Let's remember the family tree for this. Now, the fourth type is hierarchical. Now, hierarchical is when multiple classes are derived from a single class, then it is called as hierarchical class. For example, us and our siblings. For example, class 1, parent class, derived class 2, and derived class 3. So the parent class is same and the derived class are derived from the base class. Let's consider it as our parent, that is the base class. The first derived class, let's be us, and the second be our siblings. So our parents are same. So that means our the base class is same. Let us consider this as an example of hierarchical. Now let me give you all the syntax of hierarchical. Let's say base class, mm, derived class, method, base class. This is for the first one, derived class, base class. Now let's say this is derived class 1 and the second one is derived class 2. Let us consider um, the hierarchical as our example, the multi-level as the example of the family tree. I think that will help you all understand inheritance much better and remember inheritance much better. The last one that is remaining is hybrid. Now, hybrid is basically using multiple types of inheritance is known as hybrid inheritance. For example, combining single plus multiple or single plus multi-level or single plus hierarchical or multi-level plus hierarchical or the either way around. That is what is hybrid inheritance. So there are basically four types of inheritance which you need to remember, and the fifth one you all can combine, thus becoming a hybrid inheritance. I hope the four inheritance, I hope that all five inheritance are clear. Make sure that it is clear as inheritance is an important topic in OOP. I will see in next lecture we will get codes on inheritance so that you all will understand inheritance much better with the help of codes. So let's stop for today. This much is enough for today. Make sure that you go through the inheritance. Make sure that you understand inheritance. What are the four types of inheritance? What are the total basic five types of inheritance? Let's do a quick revision. Uh, Sorry, let's do a quick revision. Single is when one single is derived from a parent class. Multiple is when a derived class is derived from multiple base class. Multi-level is, let's remember the family tree, where one parent class derives a child class and that child derives another child. And then the hierarchical, where multiple classes are defined from a single class, then it is called as hierarchical class. So that's it for today. Let's meet in next lectures. Thank you. Hello everyone, welcome back to Imperium. So this is our extension video of inheritance. So in last lecture, I taught you all about inheritance and types of inheritance. So today we're gonna see the types of inheritance with code for each one of them. So let's begin. Let's start with the first one, single inheritance. Now, single inheritance is basically inheritance where only only one child class is derived from the parent class, or let's say only there is only one derived class from the base class. Let's get into the example. For example, your base class animal is the base class public. Now you all are supposed to know what this is, as I have explained you all this in the previous lecture, that this is the access specification method or access specifiers. There are three types of access specifiers: public, private, and protected, and this is public one. So void sound, see out animal makes sound. Now void is a return data type. Okay, let's get here. If I write your int rather than void, I will have to write your return 0. And if I write void, I do not write here return 0. That is the main difference between int and void. Let's move now. See here, using the syntax of class, semicolon, this is the end of class, this denotes the end of class. Derived class, class dog, public animal. This is the syntax of derived class which I gave you all in the last lecture. So class dog, we have made public animal. We have taken animal class as public. Here also we have used the access specifier as public. Void sound, see out dog barks. Now sound here and here is a function where it says see out, and void, like I said, it is the return data type. Just because we have used void, we do not use return 0. If it was to be int, we use return 0. For example, here it is int main, here we use return 0. If here would have been void main, here we are not supposed to write return 0. That is the main difference between int and main. Oh, sorry, int and void. So now class dog has ended here, as we can see, according to the syntax, according to the semicolon. Now int main, the main function. Here we create an object for the derived class dog, my dog. Here my dog is the object of dog. Now calling the method my dog dot sound. Now this is my dog is the object and dot sound is calling it. Now what is sound? My dog. So my dog dog. So this is the derived class dog, which object is my dog, and my dog is calling the sound. First it is calling this one. First it is calling this function. This function will give this output. Now creating an object of the base class animal, my animal. As you all know, in the previous lecture I have taught you all how to make an object, how to create an object, and how to create a class. So this is basically the extension of that lecture as well as extension of inheritance. So now here my animal is creating the object of base class, and now my animal dot sound is calling of this sound function, calling of this sound function in the int main. As usual, in the end return 0 and we end the program. I hope the program is clear. I won't explain hash include IOStream every time because I have done that, as IOStream is a library. I hope that is very clear. How to write a class with this example is clear. How to write a class, what are access specifiers, it is clear. How do we denote that, what is the syntax for that, and this is how we write code in the class, and this is how we end the class. This is the crucial thing, as I told y'all. I hope this is clear. Now let's run the program and see the output. As you all can see, the output is dog barks and animal makes sound. Animal makes sound. So our program has been executed correctly. Now the first output was dog barks just because we have taken the object of, yeah, we have created an object of derived class and we have called my dog first. If we would have called my animal dot sound first, then the output would have been animals make sound and dog bark would have been the second one. Let's try it out. Let's see. Hmm, capital my dog sound. Let's compile it and run. Okay. So here we have not declared the object before calling the function, thus it is giving us an error. Now let's run it. See, now our first output is animal makes sound and the second one is dog barks. So I hope the single inheritance is clear to y'all. Please make sure that you go through this code. It is very simple. Inheritance is very simple once you understand. This is also an important concept of OOP. I hope you make sure to go through this program. It is hardly of 38 lines. Make sure you go through this. Let's move on to the second one. That is multiple. Now, multiple inheritance is an inheritance where, for example, multiple base classes are used to derive a single class. For example, A and B are used to derive C. Now, let's look into the program so that it will be more clear. Base class number one, class animal. Public, void sound. See out animal make sound. This is the same as the previous one. Base class 2. Now this is the base class 2. Class bird, public void fly. Now here we have used the function void fly and see out birds can fly. Now derived class with multiple inheritance. This is how um we use multiple inheritance. This I have given you all the syntax. You can refer that. So class bat. This is a derived class. Class bat. Public. We have made the base class as public animal, comma public bird. That is multiple inheritance. That is class animal and class bird, two of the class. For example, A and B are used to create class bat, that is C. Public void special ability. Now here we have taken a complete new function where it says see out bat can fly and make sound. Here is the end of derived class. I hope this is clear. This is not very complicated. This is simple to understand. Just pay a little bit of attention and you all will get this. Now the main function int main bat my bat. My bat is an object. Now we have called your my bat dot sound, my bat dot fly, and my bat dot special ability. Now this is what I meant by saying inheritance. Now my bat dot sound. This is the derived class bat. Can you all see that this has the my bat void fly function? No, right? Now animal is, sorry, the bird is the parent class. Thus class bat, that is the child class, can derive the properties from this class, that is void fly. Thus bat can use the functions void fly just because it is derived from this class. I hope now it is clear what inheritance basically means. So this is how my bat dot sound, my bat dot fly, and my bat dot special ability is. Return 0 and end of the function. Let's compile it and see. Yeah, as you all can see the output, animal makes sound, bird can fly, bat can fly and make sound. So this was an example of multiple inheritance. I hope it is very clear to you all. Go through this code. These codes are not very difficult. It is very easy to understand. This code is hardly of 40 lines, but these codes are very easy. So we are done with single inheritance and we are done with multiple inheritance. Now let's move on to multi-level inheritance. So multi-level inheritance. Now multi-level, as I said in the previous lecture, multi-level is where one class is derived from the other and the same class gets derived. That is, there is one parent class, a child class is formed from the parent class, and then again a child class is formed, but from the child class itself. That is, I have given you all the example of the family tree to remember how it was, how you can make it simple to memorize it. So let's look into it in the code in the form of program. Now your base class animal is the base class. We have used access specifier as public. Void sound, here the function we have used is sound. See out animal make sound. Your derived class number one, let's say class mammal, public animal. Public void breathe. Now breathe is a different function. See out mammals breathe air. Now derived class 2, class dog, public mammal, public void bark, see out dog barks. Now, how we can identify it as multi-level as C, there is a base class, class animal. Now, mammal is derived from class animal. And then there is a class dog, which is derived from class mammal. I hope it is understood that dog is derived from mammal and mammal is derived from animal. This is what makes it multi-level. Now, int main, we have created my dog as an object. Now, my dog dot sound, my dog dot breathe, and my dog dot bark. This is used, for example, my dog dot sound. This is used to call the function. These are the basic. This is how we call the function. Now, let's see for the output. See, animal makes sound, mammals breathe air, and dog barks. This is exactly what we have used. For example, my dog dot sound. Now, where is the sound? C. The sound. This one is called animal makes sound. The second one is breathe. Breathe. Mammals breathe air. Third one is bark. Dog barks. This is exactly the order what the user is going to see. Now, I hope the multi-level program is clear. It is even, this is of hardly 40 lines. Make sure that you go through this program. Let's move on to hierarchical, our fourth type of inheritance. In hierarchical, it is basically where multiple classes are derived from one single base class. Now let's see that in the program. Here's the base class, class animal, public void sound, see out animal make sound. Now I have taken all these programs a bit similar so that it becomes easy for y'all to understand and easy for y'all to distinguish between types of inheritance. Now let's see derived class, class dog, public animal. That means that it is derived from the class animal. Void bark, see out, dog barks. Derived class number 2, class cat, public animal. Now this is an example of inheritance as there are multiple classes. For example, class dog and class cat, which are derived from public animal or class animal. That is that they have the same parent. Thus, it lies under hierarchical inheritance. Now your int main. We have created the objects my dog, my dog, cat, and my cat. My dog dot sound, my cat dot sound. This is what we have used to call the function. Now let's see the output. Animal makes sound, dog barks, cat meows. I hope it is clear. I hope the program is clear. Okay, here my dog dot sound, here we have used this to call this one to call the void sound function, which is denoted in the base class, and we have used my dog dot bark here, which calls this one, and so we have used my cat dot meow, which calls this one, which calls this function. So I hope it is clear now. Let's move on to the last one, hybrid. Now, hybrid is a type where you can use multiple inheritance, not like the word multiple, but you can use a combination of types of inheritance, which is nothing but hybrid. So let's see if you all can guess which inheritance I have used here, which we are gonna learn here. So let's see. Base class, class 1, class animal. Now I think you all know the drill. Base class 2, class bird, derived class 1, class mammal, where it is derived from animal, and derived class 2, bat, which is derived from mammal and bird. So I hope you all can see which type of inheritance is used. This is multiple inheritance as one single class is derived from two classes, multiple classes, mammal and bird. And this, okay, yeah, and class mammal is derived from animal. This can be even called as a single inheritance, not multi-level, but it can be also called as single inheritance, as only mammal is derived from the animal. Now int main, again we make the objects and we call the functions. Return 0. Let's see the output. Animal makes sound, mammals breathe air, birds can fly, bats can fly and make sound. So here we have executed our programs correctly without any error. So these are the basic 5 types of inheritance, and we have completed the inheritance topic with the help of code as well as with the help of theory. I hope it is clear to you all. Just make sure that you go through every single code. Not every and every single code is not difficult. Every single code is quite easy. Every code is hardly of 40 lines. Make sure that you go through these codes. These codes are very easy to understand. Inheritance is not a heavy concept. So that is it for today. We will meet in the next lecture. So that's it. Thank you. Hello everyone, welcome back to Imperium. So today's lecture is gonna be about inline function, friend function, and constructors. So without further ado, let's start. So inline function and friend function are very small topics. So let's start. I'll explain you all the topics with the code itself, with the help of code itself. Now, inline function is basically a function that is used or that is written in a single line. Let's see first what inline function is in theory, and then I'll explain you what inline function is with the help of the given code. Inline function in C++ is a function expanded in a line at the point of function call. At the point of function call. When the function is declared as inline, the compiler attempts to replace the function call with the actual code of the function. This can reduce the overhead of the function call. Now, inline keyword is used. For example, in this program, inline, the keyword inline is used. Inline int add, int a, int b, return a plus b. Now, your return a plus b, as we have used int, the return data type. In int main, int x is equals to x is equals to 5 and y is equals to 10. Here we have declared the value for x and y. Int result, now we have given the string, or let's say we have used the word result to store the result or to store the value. Int result is equals to add x y. Now here we have calling the inline function add. Here we are calling the inline function add, as we have used the keyword inline. First, we do not need to write the whole function. That is, there is no need to write the whole thing. Just we can write the name of the function, that is add x comma y. Now see out the sum is, and then we use this to print the result. Now let's execute this. Let's compile this and run this. Okay, the sum is 15. Now, as we can see, we have executed our program successfully without any errors. So this was basically inline function and friend function. So this is the friend function. These are very simple and very small topics. You do not need to bang your head over these topics. These are hardly 20 lines. So I hope inline function is clear. So inline function is basically a function which you write in a single line. Inline function basically is a function that you write in a line, and the compiler calls the code. For example, here add, we have written the inline function. Thus, the compiler will run this. The compiler will call the function here. In place of the function call, the compiler will replace it with the code itself. I hope it is clear and I'm not confusing. So this is basically the work of inline function that do not complicate the program. And we use inline function when there is very frequent use of the function. So in place of writing that code again and again and again, we give the keyword inline to that function and then we call the function. So I hope inline function is clear. Let's move on to the friend function. Now, friend function is a function which is declared in the class, and friend function is a function which can access the private and protected part of the class. That is the private and protected members of the class. Okay, so as I said, that friend function is a function with which we can access the private and the protected part of the class. Let's see that with the help of this example. So, class person, private, we have privated the age, public person int a, age a. So let's say we have used the friend function. Now here, how we define the friend function is that we use the friend keyword. Here we have used the friend keyword. Now void show age is the function, and the just because we want to make this function the friend function, we have added the keyword friend. This is how we declare the friend function. Now end of the class. Void show age, person p see out age. I hope you all know this now. This is used to give the output that is see out, and p dot age will give the age of the person p. Now int main. Person 30. Now this person is the class person and the second person is the object person. That is, we have created the object of class. I hope you all are clear with this. We have taught this, we have learned this in the previous lecture. So person 30. Now 30 is the age. Show age person. Now show age is the function that we call for person, the object person, and then return 0. Now let's see, let's run this program. As you all can see, we get here age 30. So our program has been executed successfully without any errors. So this is what basically friend function is. Now int age. Age is private, thus we cannot access the age outside. Okay. So here, just because we have used the friend function, we get to see the age of the person, that is 30. That is the reason why we could see the age of the person, that is 30, in the output. I hope I am clear with inline function and friend function here. Now to um, let's move on to constructors. I think just go through the code once of inline function and friend function, and then we'll start constructor. Okay, so let's start with constructors. Now, basically, there are three types of constructor. That is default constructor, parameterized constructor, and copy constructor. So let us first see what a constructor is. So basically, constructor is a special member function that is automatically called when an object of a class is created. The primary purpose of a constructor is to initialize the object's data members. Now, let's just see what constructor is basically with the help of program so that you all will understand what it is. Okay, now I think you all are very familiar with the first thing, that is hash include IOStream using namespace as std. And I think you all are now familiar with the class. How do we define class? How do we write the class? So here we have used the class car, private, model, string model, int year, public car. Now see this car here, we have used car. Now here in the brackets we have nothing. That is, these are the empty brackets. Thus it is called as default constructor. Now default constructor is basically a constructor where you either do not give any values or the values you take as it is. So here we do not give any value, so thus that is default constructor. Now model is equals to unknown, here is equals to 0. Void display, see out model, model, year, year. I hope this is clear now. Int main, okay. Int main car, my car is the object. Now my car dot display info is used to call the function. It is used to display return 0. Now let's run this program and see the output. See model unknown year 0. So basically, this is what a default constructor is, where you do not write anything here. Now let's see parameterize so that you'll understand what it is. Now see the same example that we have taken here in default, it's just car and brackets, nothing in the brackets. Where in parameterized here it is car string m and int y. That is parameterized. The arguments are given. That is the main difference between default and parameterized. Now let's see parameterized with the help of code. Now you all will understand what it is basically. It is the same code. Class car private string model int year public parameterized constructor. That is because we have used the arguments, that is string m and int y in it. Model is equals to m, year is equals to y. Void display, see out model, model, year, year. Int main car, my car. Now my car is an object and Toyota and 2022 are given the model and the year. Now my car dot display will display, it is called to display this, it is a function called to display return 0. Now let's run this program and see the output. Okay, as you all can see, model Toyota and year 2022. So I hope it is clear. The default constructor, go through this code once. The default constructor, that is this, and the parameterized constructor, these are the basic difference. Just go through this code once, default constructor code and parameterized constructor code. It is not very difficult, but it is okay, it is simple. Just you all need to understand, you all need to keep the concepts crystal clear. That's it. The third one is the copy constructor. Now the third one is the copy constructor. Copy constructor is basically a constructor that copies the constructor that is previous to it. So let's just start with the program. I hope it will be clear eventually with the program. Hash include iostream using namespace std. Class box private int length public box int1 length is equals to 1. Now a copy constructor box constant box and b length is equals to b dot length. Now here it is a parameterized constructor as we have given int1 as the argument to the box. Now here we are copying the value of length from the existing object, that is length is equals to b dot length. Now here and b, here b is the object of box. Copy constructor is nothing but a constructor created just to copy the previous constructor. That's it. Now void display, see out length, length, int main, box, box 1 is the object. Now 10 we have given a 10 as length. Box 2 is equals to box 1. Use the copy constructor to create a copy of box 1. Now box 1 dot display length, box 2 dot display length. Now let's run this program and see the output. Length 10, length 10. Now as you all can see, box 1 is length 10 and box 2 is length 10. That is because the copy constructor has copied the length of the first one, that is box 2 is equals to box 1. Here we have given box 2 is equals to box 1. Thus the length is gonna be same. Thus the length remains the same. I hope we are on the same page here, and I hope I am clear with the types of constructors and inline and friend function. These are very small topics and very easy topics. So let's just revise once shortly. So inline function is basically a function which is written inline. The compiler calls the code in place of the function. Inline function is basically used when a function, there is a need to call the function multiple times, thus inline function is used. And friend function is a function which we declare, which can access the private and protected part of the class. Default constructor is a constructor with default values or no values, for example your car. The same parameterized is where arguments are passed. The third one, the last one, the copy constructor is a constructor which copies the constructor that is previous to it. So I think we are clear. Now that is it for today's lecture. We will meet in the upcoming lectures. Thank you. Hello everyone, welcome back to Imperium. So in our today's lecture, we're basically gonna cover what are pointers, and today we're gonna see four small topics. That is basically first one is what is pointers, second is this pointer, third is void pointer, and the fourth one is null pointer. These are the four small topics that we are going to cover in today's lecture. So today's lecture will be dealing on pointers itself, and we are going to finish the pointers. So let's start. In C++, pointers are variables that store the memory address of another variable. Rather than holding data directly, a pointer holds the location where the data is stored in memory. So a pointer basically, for example, let's say int a is equals to 10. Now a is a regular variable. Here we have stored 10 is equals to a. Now int star p or asterisk p here, this is the syntax of pointer where we use star in front of a variable. That means it is a pointer. Now int star p is equals to and a. Now this and a will hold the address of variable a. So this is basically pointer, and this and symbol is basically that which contains the address. So the pointer, that is star p, is equals to address of a. Now a stores the value 10, but star p will store the address of a. That is basically what a pointer does. It does not store the value, but it stores the memory address of the variable. This is the major concept of pointers. So I hope you all are clear with what basically a pointer is. What is the job of pointer? So pointer is nothing but which stores the memory address of variable and not the value of variable. I hope I'm clear. I'll repeat myself again. Pointer is something that stores the memory address of the variable and not the value of variable. In this case, the pointer will store the address of variable a and not the value. That is, it won't store 10, but it will store the memory address of a. I hope I am clear. This is what basically a pointer is. Let's move on to this pointer. Now in C++, the this pointer is a special implicit pointer that is available in non-static member functions of a class. This pointer to the this points to the current instance of the class, meaning it holds the memory address of the object that is evoking in the member function. Now let's see this with the help of example. Hash include iostream using namespace std, class box, public int length. Here we have used constructor. I hope the constructor is clear to you all. We have studied constructor and types of constructors in previous lecture. So here it is a parameterized constructor as an argument is passed between. Now box int 1 length is equals to 1. Member function to display the address of current object. Void show address. See out address of this object. This see out length of the object. This pointing to length. Using this to access member. Int main box 1 10 box 2 10. Now here box 1 and box 2 is the object created of the class box. Box 1 dot show address, box 2 dot show address, return 0. Now in this example, this points to the current instance of class box 1 or box 2. The this pointer helps us access the object's length and print the address of the current object. Now let's compile this and run this program. This pointer. Now let's run it. Okay, your address of the object is 0x6FFE. Length of the box is 10. Address of this box is this, and the length of the box is 20. Now, address of this object, here we have used this pointer. Now, as this is pointer, thus it will store the memory address and not the value. Thus, in the output, we can see first that it is the memory address and not the value. I hope now the pointer is clear. Now the second one, length of the box, this is equals to length. Now this is pointing towards the length. Thus here in output length of the box is 10. I hope this pointer concept is clear to you all. Pointer. Now let's move on to the null pointer. Include IOStream using namespace std int main. Now int pointer ptr. Now here ptr is a pointer is equals to null pointer. Here we have initialized the pointer to null. If ptr is equals to null pointer, see out the pointer is null, which is true in our case, else see out this pointer is not null. Now here ptr is equals to null pointer. We have given this as null pointer. We have defined it as null pointer. Thus, see out it is gonna give the pointer is null. Now, basically, what is a null pointer? Null pointer is a pointer whose value is null or whose value is not defined, or does not exist, or the pointer is empty. That is the basically meaning of null pointer. That is what is the main concept of null pointer. Now null pointer is just used, for example here how it is used, ptr is equals to null. That is the main basic thing of null pointer, that is it is empty. I hope null pointer is clear. It is not very difficult, these are very small topics. The last one is void pointer. A void pointer in C++ is a special type of pointer that can point to any data type, but it doesn't have a specific type associated with it. It is declared using the void star syntax. Since it does not have a type, you cannot dif- differentiate a void pointer directly without first casting it to another pointer type. So what this basically means is you'll understand through the program. Hash include iostream using namespace std int main, int num is equals to 10 and float pi is equals to 3.14. Now void star ptr, this is declaration of a void pointer. Here void pointer points to an integer, that is ptr is equals to and num. See out integer value, see out pointer num. Float to a pointer ptr is equals to and pi, see out float value, return 0. Let's compile and run this program. Okay, let's compile and run. Void. Yeah, so as you all can see, integer value is equals to 10 and float value is 3.5. That is, we have used the void pointer in the int section. That is, we can denote the void to the int and pi. That is, the void pointer can be accessed or can be declared to any type of data members, for example int, float, etc., which does not have its own data type, but it can be accessed or it can be declared to any data type. So that was it for today's lecture. Today's lecture we have completed pointers. So what is basically a pointer? Which stores the memory address of the variable and not the value of the variable. Pointer stores the memory address of the variable. Now this pointer is a pointer which actually points to the access member. This pointer is the pointer which stores the memory address of the pointer, which evokes the access member. That is the object that evokes the data member. Null pointer is a pointer who is empty or which has the value 0 in it. Void pointer is a pointer which can be associated to any data type which does not have a data type of its own. So I hope we are clear with this, and let's meet in the lectures further so that we complete our syllabus. The next lecture will probably be about polymorphism. Okay, so yeah, stay tuned for the lectures and thank you. Hello everyone, welcome back to Imperium. So our today's lecture is gonna be on polymorphism. Let's start. Polymorphism is basically exist means more existing more than one form. Polymorphism is one of the concept of OOP. It allows object of different class to be treated as an object of the common base class, and it enables a single function or method to behave differently based on the types of object it is acting on. In simple terms, polymorphism means many shapes. You can use the same function or operator to perform different tasks based on the content. For example, let's say there is a class draw. Now, let's say you can draw circle, rectangle, polygon, diamond, etc. So, the main class draw is going to remain the same, and you can use draw with the following classes, that is, draw, circle, rectangle, etc. So, that is what is the basic meaning of polymorphism, existing in more than one form. For example, let's say a woman, she is a mother, she is an employee, she is a sister to someone, she is a mother to someone, and she is a wife to someone. So the woman remains the same, but the role she plays is definitely what means by polymorphism. I hope the basic idea of polymorphism is clear. Polymorphism is also an easy topic, but a very, very, very important topic. So let's start with polymorphism and types of polymorphism. I hope polymorphism is clear, not with the definition that I have given y'all, but with the example that I have explained y'all. So let's start with the types of polymorphism and let's understand polymorphism with the help of codes so that it will be more clear. Now, there are basically two types of polymorphism. One is compile time polymorphism, and the second type is runtime polymorphism. Now, how compile time polymorphism is achieved? It is basically achieved using two factors, that is function overloading and operator overloading. Now, we'll be seeing this in the program next. So, what is compile time polymorphism? Compile time polymorphism is basically polymorphism at the time of compilation, and runtime polymorphism is polymorphism at the time of the runtime of a code. Let's just move forward with the code so that it will be more clear and y'all will get me with the help of codes. Y'all will understand me eventually further. Let's move on to the first one, that is function overloading. Now, basically, what is function overloading? Function overloading means that there are multiple functions with same name, but those functions are differentiated how with the help of their values or arguments. For example, here in this function, in this program, class print, here the function void show int I, see out integer I. Now the same function is used here, that is the same function name, that is void, here was show, here is the same show, but the argument that we have used here is double D, and the first one was int I. So this is function overloading. Function overloading basically means the name of the function is same, but the function is differentiated on the basis of its parameters, that is the arguments. Now the third one is void show. Here it is string s. Thus, show function remains constant in three functions, but it is differentiated with the data type, that is int I, double D, and string s. I hope it is clear. Now int main print object. Now object is the object that we are created of the class print. Object dot show 5. where 5 is an integer. Object.show 3.14, which it is a double value. Object.show hello is a string. Now let's run this program and see the output. Now, as you all can see, the output is integer 5 double 3.14 and string hello. So this is what a function overloading basically means. Now, this is a type of polymorphism, that is compile time polymorphism. It is achieved through two factors, that is function overloading, and the second one is operator overloading. So now we are done with function overloading. I hope it is clear. It is very simple. It is very, very important, and it is very, very simple as well. Just listen to my instructions carefully and it will be crystal clear. So here the function name remains the same, but the argument changes. For example, void show, the name of the function is constant, but the arguments changed. That is basically what is a function overloading. Now let's move on to our second topic of um, compile time polymorphism, that is operator overloading. Now, basically, operator overloading is that we overload the operators, for example, plus, minus, multiply, etc. Operator overloading is basically how we want the operator to work. That is how we define in the program. Now, let's see that with the help of program. Hash include iostream using namespace std, class box, public int length, box int 1, length 1. Construct to initialize length. Now overloading plus operator. Here we are going to overload the plus operator. Now box operator plus constant box and b. Now and b is the object. Return box length plus b dot length. Returns a new box object with combined length. Now int main. Here this is where we have overloaded the plus operator. Int main box 1 is the object of class box. Box 1 is equals to 10, not is equals to box 1 10, box 2 20. Now box 3 is equals to box 1 plus box 2. Using the operator overloaded plus, using overloaded plus operator. So here basically what it is gonna do, it is gonna add box 1 plus box 2, that is it is gonna add 10 plus 20. See out box 3 length is equals to box 3 dot length. Explanation: we define a class box with an integer member length. The plus operator is overloaded to add the length of two objects. This operator returns a new box object whose length is the sum of two objects. In the main function, we create two objects, box 1 and box 2, and then we use the overloaded plus operator and add them together, resulting in the new box object box 3 with the combined length. I hope it is clear. So basically, we overload the operator to get the result how we want. That is, we can modify the operator. Here we have modified the plus operator to sum up the lengths of the box and give us the value. Now let's run this program. Uh, yeah, yeah. Let's compile and run this program. Let's name it as OPE, as an operator overloading. So here the output is box 3 is equals to length 30. Now here it has given us 30, as we have said box 3 is equals to box 1 plus box 2. That is 10 plus 20. I hope operator overloading is clear to you all, and compile time polymorphism is also clear. The polymorphism topic is also, it is very simple. It is not a very big deal. I hope it is clear. If you all have attended the lecture very properly, you all will definitely understand this. These are very simple topics. So this was function overloading. That is the function with same name but different arguments. Operator overloading is how we overload the operator to get the result. Now let's move on to the second type of polymorphism, that is the runtime polymorphism. Now runtime polymorphism is achieved by using function overriding. Now, what does function overriding means? Function overriding is basically writing the same function again. Overriding is a this okay. So runtime polymorphism is achieved with the help of function overriding. Now let us understand. Okay, function overriding. Yeah. So let us understand what is function overriding with the help of example. So basically, what is function overriding is that we write a function in the base class and we use the same function as it is in the derived class. So that is nothing but function overriding. So let us see through the program. So you all will get a better view of function overriding. The hash include iostream using namespace std class animal. Here we have created a class animal, public virtual void speak. Now here void speak is the function that we have used. Now virtual, this is an important concept. Virtual. Now here we want to use the void speak function in the derived classes as well. So we need to make the function in the base class virtual. If we do not make that, we cannot override it. So that is basically what virtual keyword means or why virtual keyword is used. So this is clear to you guys. Now class dog is derived from class animal, that is public animal. We have taken the derivation that is public. Now this is inheritance. I have taught inheritance in the previous lectures and types of inheritance. We are done with that. I hope it is clear to you guys. Make sure that it is clear because inheritance and polymorphism is an important topic in OOP, are an important topic in OOP. So let's move forward with this one. Public void speak. Now override. Override is a keyword that we use when we override and function. Thus, here we have overridden void speak. Thus, we write override over here. Now override see out dog barks. End of class. Second derived class is class cat. Now this cat is also derived from the public animal. That is, it is derived from base class animal. Public. Void speak override. Here also void speak. Here speak is overridden. Thus speak is overridden in class dog and class cat. I hope it is clear. See out cat meows. Int main. Animal 1 star animal star animal 1 is equals to new dog. Animal star animal 2 is equals to new cat. Base class pointer to derived class object. Animal 1 arrow speak, animal 2 arrow speak. Now this is basically used to call the functions, that is speak in the classes. Delete animal 1 and delete animal 2. This is basically used to clean up. If you do not write this, it is fine, the code will still execute. Now let's run this code and see the result. Let's see the output. Yeah. So the output is dog barks and cat meows. So here, the dog barks and cat meows. Your animal 1 is equals to new dog and animal 2 is equals to new cat. Thus, animal 1 is new dog, so it will call this function, that is the dog barks, and animal 2 is cat. So animal 2 arrow speak will call this, that is see out animal meows, cat meows. I hope it is clear what function overriding is. Make sure that you go through this code. This code is very simple. I hope you all have understood what polymorphism is and what are the types of polymorphism and how do we achieve polymorphism. So this yellow thing is basically warning. These are not errors. The program can be executed. Now let's just revise this. Let's do a quick revision, short revision. Now polymorphism, what is polymorphism? Polymorphism means existing in more than one form. So there are basically two types of polymorphism, compile time polymorphism and runtime polymorphism. So compile time polymorphism can be achieved using two factors. So one is operator overloading and the second one is function overloading. Now let's see what is function overloading. In function overloading, the name of the function remains same, but it is differentiated with the help of data types or arguments, that is different arguments or data types. For example, your int I, double and string, whereas the show function is the same. The second factor is operator overloading. In operator overloading, we overload the operator how we want the operator to be used. That is what operator overloading basically means. Now, this was compile time polymorphism. Now, let's move on to runtime polymorphism. Runtime polymorphism can be achieved from function overriding. Now, basically, function overriding means using the same function as it is in the base class as in the derived class. So, that is what is the meaning of function overriding. I hope these topics are clear. These topics are very easy. Make sure that you go through the codes. This is the operator overloading code. This is the function overloading code. And this is the function overriding code. Make sure that you go through this code, and this topic is very easy, and make sure that it is clear. So that is it for today's lecture. So we are done with polymorphism completely. Let's meet in the next lectures. Okay, so yeah, thank you. Hello everyone, welcome back to Imperium. So today's topic is gonna be today we're gonna see basically four topics. These two, the first two are somewhat related to polymorphism, and the next two are basically the keywords which we'll be explaining. So today's topics are very small and very simple, and we'll be done with these easily. So let's start. So pure virtual. Now, pure virtual, I'll make you all understand this through the code with the help of the code. Let's start with the code. Hash include IOStream using namespace std. Class shape public pure virtual function. Now here virtual keyword is used, and for example the function is void draw. Now as you all know, void is the return data type, draw is the function, is equals to 0. Now this is what pure virtual function is. In pure virtual function, we define the function that is draw is equals to 0. That is nothing but virtual function. That is nothing but pure virtual function. Pure virtual function is defined by the function name is equals to 0. Now end of class, derived class, let's see class circle, public shape, public void draw, override. Now you all know what overriding is. We have done this in the previous lecture. See out, drawing and circle, and L. Int main, shape star shape is equals to new circle, shape arrow draw, delete shape, deletion is nothing but clearing up space, return 0. Now here cannot create an object of shape because it has pure virtual function. Thus shape this would cause an error. So this is the reason why we create an object of circle, and this is why shape into shape is equals to new circle. If you all remember, we have done the same thing, that is animal into animal is equals to new dog and new cat. We have done as an overriding function. Here we are doing the same thing. Here also we have overridden the function. I hope y'all now know the difference between overriding, function overriding, and function overloading. Make sure that you know the difference. It is very important. It is very crucial as well. So here we have taken this as shape into shape is equals to new circle, as we cannot make the object of the class which contains the pure virtual function. I hope pure virtual function is clear. A function which is denoted like this, that is the function which is denoted with is equals to 0 is basically called as pure virtual function. So that was it. And now the second topic is abstract class. Okay, so our next topic is abstract class. So basically, abstract class is a class which contains minimum one virtual function. So as we know, virtual function was a previous topic. So virtual functions are defined by, for example, here, area is the function is equals to 0 is the pure virtual function. That is the definition of function. That is the definition of pure virtual function. Now, your abstract class basically means that whatever class or whichever class contains minimum one pure virtual function, that class is called as abstract class. So the actually the definition says minimum one. That means minimum one is the compulsory requirement, and more than one can work. Thus, this is an abstract class as it contains minimum one pure virtual functions. So this was the topic of abstract class and virtual function. So these are the very small topics that we were remaining from the polymorphism chapter. The next one is mutable. Now, mutable is a keyword which we write in front of the word. For example, if we have chosen a word and we have given it as the constant keyword so that the value of the number does not change. But here, with the mutable keyword, the value of the number can be changed no matter what, if it is denoted as constant or not. For example, let's say we take a is equals to 5 and we add mutable in front of a, that is the keyword. Now, when we add the word mutable, the value of a can be changed. That is, it can be incremented, it can be decremented, it can be multiplied, it can be divided, no matter what, but the value can be changed. That is the basic concept of mutable. As the word suggests, the value can be mutable. Now, let's see the program. Class, my class, private int x, mutable int counter. See, now mutable is the keyword that we have used for counter. Thus, the counter value will be mutable. Public my class int val int get x constant return x. Mutable members can be modified even in constant method. This is what I mean when mutable keyword is used, no matter what the word is or whatever the value is, even if it is stated as constant, the value can be changed with mutable keyword. Let's directly jump to int main. Constant my class object 5, create a constant object. Std out. Okay, here we have written std out as we have not used your hash. Here we have not used using namespace std. If we use your using namespace std, we could directly write your c out. I hope now it is clear why we write using namespace std after hash include. And if we do not include that, this is how we are supposed to write. That is std dot 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 c out, c in, whatever. I think it is clear now. Initial x object dot get x, c out initial counter object dot get counter, object dot increment counter object dot increment counter, c out counter after increment, return 0. Now let's run this program and see the output. Okay, as we can see, initial value is x, initial counter is 0, and counter after incrementing is 2. Now here the value is 2 as we have incremented it twice, this year and here. Now, as you all can see, as you all can see here, the initial counter is 0, but we have considered this as mutable. The counter can be mutable. Mhm. The counter can be mutable here. Thus, after the program executed, the value is 2. I hope it is clear why we got year 2 and year 0. Thus, the value is muted. This is the work of the keyword mutable. So that is it for today's lecture. In next lecture, we will be seeing about exception and exception handling. So let's meet in the next lecture. Thank you. Everyone, welcome back to Imperium. So our today's lecture is gonna be on exception handling. So basically, first of all, what is an exception? So exception is a problem that arises during the execution of a program. So basically, exceptions are basically errors which arise during the execution of the program. Your example will be, for example, dividing by 0. As you all can analyze that the division will take place, but just because the division is by 0, it is not a fixed value. Thus, that is going to give an exception, that is going to give an error. So the program is going to execute. There is no error in the program, but there is error in the division. So that is nothing but exception. So in C++, in OOP basically, exceptions are handled using exception handling. So there are basically three keywords for exception handling. Let's begin with that. So the first one is throw, catch, and try. These are the three keywords, that is throw, catch, and try. Let's start with throw. Now, throw is used to throw an exception with an error occurs. Throw is used to throw the exception basically. Now, try block is the block where we write the code where we analyze that there could be an exception here. So that is the code that is written in the try block. And the catch block, basically catch block is the block that catches the exception and then handles it. Throw used to throw an exception when an error occurs. Try wraps the code that might throw an exception. Catch catches the exception thrown and handles it. So let's see the syntax of try, catch, and throw block. Throw. The throw keyword is used to throw an exception. Syntax throw an expression. Try. The try block is used to define the sections of code that may throw an exception. So whatever code we write in try block might throw an exception, that is the possibility. So thus we write the code in the try block. It is followed by one or more catch blocks to handle those exceptions. Syntax try code that might throw an exception. So this was the syntax for try. Now let's see the syntax for catch. The catch block follows the try block and handles the specific exceptions. You may have multiple catch blocks to handle different types of exceptions. The syntax for that is catch exception type and E handles exception of type exception type 1. So I hope you all are clear with the three keywords that are used in exception handling and what are those used for, what are the basic syntax. Now let's dive in to the program of dividing by zero, which is an example of um, exception handling. So let's see the program. After seeing this program, it will be more clear to y'all how the exception handling basically works. Now let's see hash include iostream, hash include std except. This is for throwing exceptions using namespace std int main int numerator denominator. We take numerator and denominator as two words. C out enter numerator. C in numerator, C out enter denominator, C in denominator. Uh, that we store the denominator in the word denominator and numerator in the word numerator. Now try. Here we have used the try block. Now if denominator is equals to 0, throw 1. Here if the exception is caught, it will throw 1. Else in else block int result is equals to numerator by denominator. Now C out result and L. Now catch block. As we all know, catch block is followed by the try block. Now catch int D. Now here we catch int as we have taken int here and we throw 1. The exception is 1. So catch int D. See out exception caught. Print the error message. Return 0. Now let's execute this program and see. Okay. Enter numerator, let's say 22. Enter denominator, let's put 0. See now exception caught. This is giving exception caught as we have entered the numerator, we have entered the denominator as 0. Now it went inside the try block. It went inside the if statement. If denominator is equals to 0, which is true in this condition, thus it has thrown an exception. Now when the exception is thrown, the control has moved towards the catch block and thus this will not be executed as the control has been shifted to the catch block. Now catch block, here it says output exception caught. Thus our output is exception caught. Now let's run this program again. Compile. Now let's run this program again. Let's say denominator 15 and sorry, numerator 50 and denominator 5. Here the result is 3. Now here there was no exception, thus it entered the try block It entered the if block, but the statement became false, so it exited from the if and entered here. So int result numerator divided by denominator will give the result 3. See out result, we can see the result as 3. As there was no exception was thrown, thus the catch block did not work. I hope now it is clear what an exception basically is. So this is how we handle an exception. These are the three keywords that so, these are the three keywords that we use, that is throw, try and catch. And this is an example of how and exception handling works. So this is it for today's lecture. Today's lecture is very small lecture. In next lecture, we will be seeing multiple catching and rethrowing examples. So stay tuned for the next lectures. And these lectures aren't very difficult. These are very simple. Exception handling is basically an easy concept. So pay attention and go through these codes again. This is hardly 30 lines code. So make sure that you go through this code, and we'll meet in the next lecture. Till then, thank you everyone, and welcome back to Imperium. So our today's lecture is on templates. So basically, what are templates? Templates in general life refer to pre-designed or pre-structured guide that help us create something new quickly and effectively. So this is exactly what we are going to do in our programming. So let's get started. Um, so this is an example of template. This is a code for template. I will get to this later. So first of all, templates are basically a pre-designed structure in which it's basically like an algorithm where we can use it for every single data type. Now y'all will get me after seeing this program so that it will be more clear to y'all. Let's move on and let's get to the program. So let's begin. Hash include IOStream using namespace std template type name t void add tatb. Now this is how we define template, how we define that we are going to use template. This is the syntax, that is template type name space t, and this is nothing but a function template. Now void is the return data type, add is the function name, and tatb, let's say these are the arguments. Now for this add function, see out addition of two numbers a plus b. A plus b, this is the function void add. So this complete is a function, and it is a template function. Thus we have ta and tb, and we have defined template type name t. Now we have done the same thing, just we have used a subtract, that is tatb. Here we do a minus b. Ta and here t is nothing but the template type. And let's move on to int main. See out example of generic programming. And add int 10 comma 20. Now here this is how we call a function template. That is, we use the function name, that is add, we write the data type, that is int, and then we give the values or the arguments. The same we have done for add and subtract, and this is the same thing. Now this are the same function. As y'all can see, add and subtract are the only two functions that we are going to use, and both of them we are going to use for int as well as float. Now this is the main cause, or this is main thing why a template is used. So template is basically an algorithm that we can use for different data types. Now you all will understand this with the output of this program. Now see example of generic programming. Addition of two numbers is 30, subtraction of two numbers is 35. Now this 30 and 35 are the result of addition and subtraction int. That is the int data type. And the second one, that is this one, addition of two numbers is 30.84 and subtraction of two number is minus 30.2. These are the value for float type, for float data type. That is, we have used the same function add and the same function subtract, but we have used two different data types. So two different data types, yeah, that is int and float. So this is why we use template. We create one single function in this. That is, one single function was add, and then we use int data type and float data type. We can even use different data types, for example char, string, etc. This is the main reason why we use templates, and templates are so powerful in C++. Let's see the syntax so that it will be clear. Now this is the syntax for function template. This is the basic syntax of how we define template. That is, we write template, type name t, return data type function. Okay, so here we write first of all, while defining the function template, we write the return data. We write the return data type. That is, in this example, we wrote void. Now, void is nothing but a return data type. The second thing was add, that is the function name. And this in the round brackets, we add the function arguments. For example, ta, tb. Now, t here stands for nothing but template, and a and b are arguments. So this is how we define a function template. And for calling a function template, we call the function template by using the function name. Then we write the data type, and then in the round brackets we write values or arguments. As you all can see here, we have written the function name, that is add. Then we have the data type, that is int, and then we have the values or the arguments in the round brackets. Okay, I hope it is clear to you all. So this lecture was nothing but what are basically templates and a small example or small code of what a template is, so that you all will understand what a template is from this example and the syntax of templates. And basically function templates, this is nothing but a function template, the function add and the function subtract. This is a function, right? And we have used this function with the help of template, so it is nothing but a function template. So this lecture was basically about template and function template. In next lecture, let's see what class template is. So that is it for today's lecture. Let's meet again in the next lecture. Thank you. Hello everyone and welcome back to Imperium. So our today's topic is class templates. In previous lecture we have studied what are templates and we have studied function templates. So today's lecture is going to be on class templates. Now let's start. Now hash include IOStream and using namespace std. This is the compulsory thing that we write in each and every program. Now let's begin. So this, in the previous lecture I have told you how we define a template. So this is the same thing, that is template type name t, class box. Now this is an access specifier. Let's start with the program, because this I assume it is clear as we have done this in the previous lectures as well. T items, and now here we have used a constructor, that is box ti, where I is nothing but I is equals to item, I is item, and here t is nothing but a template. In the previous lecture how we have seen that how we use t in the two functions, that is add and subtract, where t can be anything, that is any data type. It was integer and float. And now the second function that we have used is void show items. When we call void show items, this line is going to be executed, that is the box has an items. Items is what we are going to put in the box using this function, that is items is equals to I, box ti. Now box ti is nothing but, let's assume it is a function template. Now this is the end of the class. Int main box int. Now box, the function name, int is the data type, and box number 5. Now int is a data type, so let's add a value 5. Now box number dot show items. Now show items is going to show the box has 5. That is what we are going to see in the output. The second thing that we are going to use is box string. This is how we add different data types using template. So here we have used integer, here we have used string, and here we have used double. And here we have added 5, toy, and 3.14 respectively. Now let's see the output. Okay, so as the output says, the box has 5, toy, and 3.14. So this is nothing but an example of class templates where we use the function templates or where we use the templates, basically templates inside a class. Thus, it is nothing but a class template. So this concept is very easy. I hope it is understood to you all. Make sure that you rewind the lecture and rewatch the lecture if it is not clear. Templates are basically very simple, short concepts to understand and a very short unit. So today's lecture, we are going to see two concepts, that is the class template and overloading function templates. So I assume that the class template is now clear to you all guys, as function templates was very easy and very easy to understand. The same thing we have used in the class template. We have used the same function and we have used a template inside the class. Thus it is nothing but a class templates. And I have also added the comments here so that it will be more clear to you all, and it will be more easy to understand. Now let's begin with the function templates. Overloading function templates is the second topic. Now let's start and let's write this code. It is a very small code, so let's type it out and let's execute this code. Function template. So let's start. Ha okay. Hash include IO stream using namespace std. Now here we are going to define templates, that is tmpl template class t. Now this is another concept. This let's cover this concept in this lecture itself. Now here we have used class t for defining the template, and here we have used type name t. So type name t and class t are nothing but same thing. Here class t means the template t. So people often confuse this class t assuming that it is a class, but it is not a class, it is a template. First, we prefer writing type name t, and class t and type name t are nothing but defining a template. So here we have used the class t, and let's execute this program using the class t. Class t void, that is the return data type, the function name print, t that is our template argument, and a that is our regular argument. See out. This is a function. Let's not write this. Let's write this function is with function template. Function template. Endl. Now again, void print int a. Now let's shift this on the next line so that it will be a good thing. It will be like a good practice, let's say, and it will also look good. Okay, so here let me explain you all this thing. Now here we have used void print ta. Now the t is templates, thus it can be used for anything. And here void print int, here we have given a specified data type, that is int. Thus this void will only print integers, and this void, the first void, will print any data type, and this void will print integers. See out. this this function is already now let's move on to the int main part. Print, let's say 100. Let's take this closer. Okay. Now let's say print 100. Let's say print 20. Mm-hmm. Now let's say print 123.10 and let the last one be print message. Enter. Oh no, sorry, return 0. Now here the indentation does not matter as we are coding in C++, so indentation does not matter. So here in int main, we have taken print 10, print 20, print 123.110 and print message. Now let's run this program. Okay, now see here in output, the function is ordinary function that is 10 and 20, 120 because these are in integer format that is the main format that we have given in the second function that is void print int a. So this is printed or this has been executed or printed with the help of that function. And the last two that are 1 to 3.1 and message have been printed using templates as the data type does not match as 1 to 3 is double and message is string, so it does not matches. Thus it has been executed using templates. Now I hope it is the concepts of overloading and overwriting are clear to you all, as overloading means having the same function name that is void print and void print, just the difference is its argument. Here we have given int a and here we have given ta. Now t stands for template, that is any data type is suitable. So I hope it is clear. The part of class templates and overloading function templates is clear. So that was it for today's lecture. Today's lecture we have seen class templates and overloading function templates, and we are done with the topic of templates. So in next lecture we'll probably see function template libraries. Sorry, the standard template libraries. So that is it for today's lecture. I think it is clear to you all, and please make sure that you go through this code, the class template code and overloading function code. So that is it. Thank you.
Everyone, and welcome back to Imperium. So our today's lecture is going to be on file handling, which is our last unit with respect to OOP concepts with the help of C++ language. So we are going to see file handling in this lecture. So let's get started. We'll understand file handling with the help of this code. So let's start. I expect y'all to understand basic C++ language, which I have taught so far. So let's start. Hash include IO stream. You all are familiar with this. IO stream stands for input output stream, and this is a new thing. Hash include F stream. Now F stream is used for file where where F represents file. F stream basically includes if stream and off stream, where if stream is for input file stream and off stream is for output file stream. So when you write include fstream, it includes both, that is input and output with respect to file, using namespace std int main of stream out file. Now this is a function that we use to declare file. Now example.txt is a file's name. Out file, hello, this is a file, this is what we have written to the file. Now out file dot close, this is the function that we are calling to close the file. String text, if stream in file example.txt, now this opens the file for reading. Get line, now get line function is used to read one by one line. See out, file says text endl. I hope you all know what endl does. Endl moves the pointer to the next line so that the line next to the pointer gets printed on the next line. So cout file says this is gonna print what is written inside the file. In file dot close, this function we are using to close the file. Return 0, this is how we end the program. So let's run this program, let's see the output. So here we have executed the program. The output says file says hello, this is a file. Now this was the program of file handling, where it is very small, very easy concept, nothing to stress about. The main things for file handling is that y'all are supposed to write this part, that is hash include fstream, where if y'all do not include hash include fstream, it is not going to be considered as a file. So that is one thing, and these functions where out file and in file are included, that is also crucial for file handling. So there are two types of file handling, basically two types of file opening. One is direct, that we have done using open file and close file, and the second one is using constructors, which is very complex, but let's not go there. These are the very easy stuff, and this is what is used. So I hope you all go through this, and I hope you all have understood this example and the concept of file handling. So that is it for today's video. Welcome back to Imperium. So this is the very last lecture of our series, that is OP concepts with the help of C++ language. So now that we are done with everything, I'm gonna explain you how y'all are gonna download the certificate, how y'all are supposed to download the certificate for the C++ class that we have done, for the course or for the playlist that y'all have completed. So this is the Google form that y'all are supposed to fill. Here comes a full name for certificate. Now which domain you want to get certification, that is C++ OP that we have done right now, which is my playlist, which I have explained the concepts of OP with the help of C++ language. So if you all want that certification, select this option. And now here is the main part. Here you are supposed to submit a project with you all are supposed to submit the project, and you all are supposed to build the project with the help of C++ and OOP concepts that I have taught through the videos, through the playlist. Now y'all can basically do anything y'all want. Y'all can build a calculator, it can be an easy calculator, it can be complex calculator. Y'all can use if else statements, y'all can use looping statements, y'all can use switch cases. Now that is up to y'all. Okay, that is how y'all want to do the project, because that is your project. So y'all are supposed to do the project, complete the project, and then add the project here. And I hope the project is supposed to be working. If the project is working, y'all will definitely get certificate. And the last thing, that we expect your feedback. This feedback is very important for us. It will help us to improve our teaching and our community. So we hope that you give your honest feedback. And also, these are the courses that you can go to Imperium channel and watch. If not, y'all have completed C++, not through this playlist but any other playlist, which is fine. For certification downloading, y'all are supposed to do this one procedure, and the main part is submitting the project. Once y'all are done submitting the project, y'all will get the certification. So y'all can do this not only for C++, but for the resources or for the languages and options y'all see here. So this is the last step, and this will help y'all get the certificate for the course you have watched and completed. So that is it, and I hope you all fill the form and do give your honest feedback to us. So that is it. Thank you.